interactive online training on piping and instrumentation diagram. Module 8. Line numbering. Following topics to be discussed in this module. 1. Line numbering. 2. Quiz. Line numbering system is usually implemented as per design and drafting procedures of the engineering consulting firm or the client provided specifications. There is no common, or rather standard, pipeline numbering system exists in the industry. It is solely the client or consulting firm's decision on how to designate and generate a system on their own according to engineering practices. The line numbering is an important aspect of the piping on a project and should only be created and controlled by the process piping group for the project, specifically by the designated engineer of that project. The terms line number or line designation are commonly used in the industry, which has the same meaning. The method of line numbering is where the line is best defined as a single line having an origin and a terminal point consistent with the purpose or function. An example of this might be a pump suction line. It might come from a storage tank, a power bottom, or an accumulator. It travels some distance and then splits and connects to the two pumps designated for that one service or function. This is one line. It serves one purpose or function, therefore it has only one line number. Another example would be the pump discharge that leaves both of those pumps and joined to form a single pipeline that runs to the next piece of equipment. This line also has one purpose or function, therefore it has only one number. Sometimes there is change of line class or line specification on the same line. The change in line class is most often caused by a change in pressure or material. The line might be the same size from one point to another, but includes a pressure control valve that lets the pressure down to a level that allows a lower flange rating or other material, therefore different line class. Any change in the line conditions or material causes a mandatory change in the line number, no matter which line numbering method is being used. The line numbering activity should only be done when the P&Ids are well along in the development process. As the designated engineer performs the line numbering of the P&ID, he or she also initiates the first draft of the line list or line designation table database. The LDD is another area of discussion and beyond the scope of this training. Let us generate a line number by incorporating the essential elements as below. Service, serial number, piping class, line size, finishing type. As mentioned earlier, line numbering system is usually implemented as per design and drafting procedures of the engineering consulting firm or the client-provided specifications. A more common and generic system is explained below with an example. Assume a line number with following format: service, serial number, piping class, line size, finishing type. In this example, we shall assign the following data to our line. Surface hydrocarbon rain flare FH. Serial number 001. Piping glass low temperature and CRF class 150 with material group and corrosion allowance. Line size 4-inch NPS, 100 dm. Insulation hot 4-inch, 100 mm, thick with electric heat trace. After considering the above information to generate a line number, we get FH001-R3-100-H100E. Service, hydrocarbon rain flare FH. Serial number unique to each process area 001. Piping class 150 and CRF. Material group regular temperature carbon steel oil. Corrosion allowance 3.18 mm 3. Line size 100 dn. Insulation code hot insulation H. Insulation thickness 4-inch 100. Tracing type electric E. According to piping line description, which will be provided in this example, the line number generation procedure mentioned above must be followed for all lines shown on the P&Ids. Following tables and data provide details to generate a specific line number. Line size equivalence. Service, MME. CP condensate process. CS caustic soda case. DB distillation product butane. DL distillation products LPG. DN distillation products NGL. DO distillation products other. DP distillation products propane. DS distillation products stabilized condensate. ES eutectic salt. FG glycol drain flare. FH hydrocarbon drain flare. FO open sewer drain. FR process relief drain flare. FV flare drain miscellaneous vents. FW water drain vent. GF fuel gas. GF vent gas miscellaneous and equipment. GP process gas. GR regeneration gas. GS sales gas. NF nitrogen firefighting. OD diesel. OG gasoline. OH residue gas heating oil. OP oil process. OR oil shall recycle. OS oil sales. PC stabilization overhead products. RO refrigerant other. ARC refrigerant propane. Sulfur. SO solvent. UA instrument utility air. UC utilities chemical injection. UG utilities glycol. UH utilities heat medium. UL utilities lube oil. UM utilities methanol. UM utility nitrogen. UO utilities others. US utility steam. WB boiler feed water. WC water condensate return. WD dousing foam water. Fire water. Heating water. WO water others. WP potable water. WS water site drainage. XA instrument airlets. XP process instrument leads. XS process tubing stainless. Pressure temperature rating. A 150 and CRF. B300 and CRF. C600 and CRF. D600 and CRTJ. E900 and CRF. F900 and CRTJ. G1500 RF. H1500 RTJ. I2500 RF. Material group. L low temp carbon steel. R regular temp carbon steel. P low and intermediate alloy steel. S stainless steel. V copper and copper alloys. W nickel and nickel base alloys. X non-metallic material. Z carbon steel with lining. Corrosion allowance. 0.0 millimeters. 12.00 millimeters. 3.18 millimeters. Serial number. 3-digit numbers is unique to each process area, for example, 001 to 999. Insulation code. O acoustic insulation. C cold insulation. H hot insulation. And painted, no insulation. P personal protection. Insulation thickness. 25 1 inch. 40 1.5 inch. 50 2 inch. 65 2.5 inch. 80 3 inch. 90 3.5 inch. (104 inch), 115 4.5 inch, 125 4.5 inch, 125 5 inch, 150 6 inch. Tracing type, if applicable: E electric, G glycol, or other, S steam. Hence, by incorporating the above tables and other details, a line number can be generated. The line numbering system depicted above shall be implemented in the case study for P&Id generation in Module 10. Assign the line numbers beside the information in the table below. Line number 201, NPS 100, Service DL, Class B, Material R, CA1, Insulation NA. Line number 253, NPS 200, Service PC, Class A, Material S, CA0, 2-inch, Insulation P. Line number 261, NPS 50, Service GF, Class C, Material L, CA3, 1-inch, H insulation 1-inch, tracing G. DL201-BR1-100N. PC253-S0-200B. GF261-CL3-50H50G. And this is the end of Module 8. Instrument legend to be explained in the next module.